In the Batman movies, the Dark Knight's cape pulls off a neat trick. Most of the time it billows behind him while he crumples nameless henchmen. But when Batman needs to make a quick escape, he can leap off a building and stiffen his cape so that it works like a glider that carries him into the night. One moment the cape is fluid, then the next it's rigid. It's a smart bit of engineering that engineers at Caltech and JPL have now replicated in the real world. This material, inspired by chainmail, can go from a foldable, fluid-like state into a specific solid shape with the application of pressure. Meet Chiara D'Areo and her team. She is Professor of Mechanical Engineering and Applied Physics at Caltech. Their goal is to find the optimal material for wearables. We may need to define optimality parameters that are different and more specific. The physics behind the technology will be familiar to anyone who's bought vacuum-packed coffee. The material is designed on computer and 3D printed. This chain main has some unique properties such as the chainmail can be tuned from being soft and foldable to being stiff and rigid. This type of change is known as phase transition from flexible or flowing to stiff and rigid. This thing happens when individual particles are tightly locked together. How much particles interacting to each other and how much they are stiffed and on what basis the particles are tightly locked. Chiara explains, when two coffee grains are interacting together, so they are interacting only single point and such type of interlocking system is not enough to carry heavy weights. However, if one particles are shaped like concave then it's like crescent moon, and this specific shape of particles could interact more tightly or fit more snugly with one another, just like puzzle. Chiara's team developed different type of complex 3D structures could be made to interlock, which are connecting them at multiple points. When the material is compressed in a vacuum bag, then the material become very stiff enough to support over 50 times its own weight. In parallel research, D'Areo and her team are investigating strips of polymers that shrink when heated. These strips could be woven into this new type of chainmail to create solid objects, like bridges, that fold down flat when not needed. The two materials working together could also, she suggests, create robots that can morph into different shapes to solve different problems.